Is we are going to be talking about exponential and logarithmic functions, but mainly logarithmic functions. And like I said, from what I could see earlier, both of my classes thought that this was pretty much a review of something that you've done before. You might learn a few new tricks and tips, but for the most part, just a review to make sure we're all on the same page. So when we start, the first thing I want you guys to know how to do is I want you guys to know the definition of a logarithmic function. So make sure that you guys write that down. That is the definition of a logarithmic function. It's pronounced y equals log base b of x, and it's equivalent to the exponential function b to the power of y equals x. Please do your very best to pronounce it correctly. I hear so many times students say log b x, and you definitely have to differentiate between which one's the base. So whenever you're saying the base, actually say the word base before it. So log base b of x. Yes, sir.
Anyone say 10g instead of log?
Actually, yes. Yes, I have. All right. In previous years, or in previous classes, I guess I could say, students have said that in previous years for them, they've just been asked to memorize the relationship between the logarithm and the exponential. However, I had an Algebra 2 teacher in high school that taught us this method that she called the wraparound in order to help you remember how to convert from logarithm to exponential. So I'm going to have you guys write it in your notes, and if you like it, great, use it. And if you don't like it, feel free to just kind of leave it where I put it. So write down the title of it. We're going to call it the wraparound. And here's how it works. If you start with the logarithmic expression, so if you start with y equals log base b of x, my Algebra 2 teacher taught us that, and it's not really anything magical, it's not really anything that's special, it's just a pattern to help you recognize how to convert it to the exponential form. So she told us to always start with the base, so you start with base b and she would circle it. And she'd say that you get b to the power of y, and notice that you make a little pit stop off here at y. So b to the power of y equals, and notice how we make a little pit stop at equals, and then we wrap it all the way around to the other side, so equals x. And when you write that, you get b to the power of y equals x. And that's called the wraparound. So again, that's not anything special. If you already knew how to convert it into exponential without this, that's great. But some people forget how to convert it into exponential, so hopefully this will help you to not forget that method. All right, you guys ready to try your own example of converting to exponential? Yeah. All right. I know, I can hear a couple people still writing, so go ahead and take your time, and we'll move on to the next one in just a minute.
How was the day with like 20 kids in class?
Wonderful. All right, here we go. Here's your first example. Try this one. Convert to exponential form from logarithmic form. No, you do not need to solve it. Just convert it into exponential. Did you get this as your answer? I hope so. So again, using the wraparound, if you start with the base, bless you. If you start with the base, you start with 7 to the power of 3 equals x, and that helps you to convert it into this form. So 7 to the power of 3, wrapping around the equation, equals x. Do you guys feel like you need another example like this, or do you feel like you're very comfortable converting to exponential? Very comfortable. Okay, then we're going to skip the next two converting to exponential examples, and I want you guys to see how comfortable you are converting from exponential back into logarithmic. Do you want to see one example together first? All right, if you need to, here's one example together. You can kind of, it doesn't work quite as well because it's not, you have to remember a little bit more, but you can kind of do the reverse wraparound, so you still start with the base. It's just that now you actually have to add in the word log before that. So we're going to have log base 2 of x equals 5. So there's our wraparound that time. Log base 2 of x equals 5. And that's how to convert back to logarithmic form. And By the way, you can always check to make sure you did it right by doing the original wraparound again to make sure that your answer equals what it should equal. But I'm going to have you guys try one. You guys ready to try one on your own? Yes. All right, try this one. B to the third power equals 27. Try to convert that to logarithmic form. All right, check your answer. The answer is 3 equals log base B of 27. We good with that? Yeah. Beautiful. Okay, then I'm going to skip the next one because I don't want to bore you guys with a bunch of stuff you already know how to do. What about this? Would you know how to evaluate this? Yeah. Try it then. So some of you guys are really good about figuring this out in your head, and if you are, that's great. If you have trouble or if you get to one that's difficult and you don't know how to figure it out in your head anymore, you can always revert back to converting it into exponential form. So remember that you might not know what this equals, log base 10 of 100, you might not know what it equals, but you know that it equals something, so you can just set it equal to something. And if you do the wraparound, you get 10 to the power of x equals 100. And then now it looks maybe a little bit more like something you could solve. For example, now you just have to ask yourself, what power of 10 gives you 100? What's the answer to that? 2. Beautiful. So you can write it like this. 10 to the power of x equals 10 to the power of 2. And now that they have the same base, we can say that the exponents are equal to each other. Therefore, x must equal 2. All right, let me give you one that's a little bit harder. Let's see how you guys do with this next one. Try this one. Log base 5 of 1 over 125. See if you can get that one. Again, for this one, you might not know what this equals, but it equals something. We don't know what it is, but something is what it equals. So if we do the wraparound, we get 5 to the power of x equals 1 over 125. And I need these to have the same base, so I need to both have the same base of 5. How do you take something out of fractional form like this and put it with a negative exponent? What is this? 125 to the power of what equals 1 over 125? I don't want to convert it to base 5. I'm keeping it as 125 as the base. I'm just asking how to get from here to here. What's the exponent on this? Like, what would I write here? Negative 1. Good. This is to the power of negative 1. And now I want to convert it to base 5. So if I want both of them to be base 5, I have 5 to the power of x equals, what power of 5 makes 125? 3. So that's negative 3. And now that they have the same base, I can know that x equals negative 3. Beautiful. I have one more of these for you guys to try. Are you ready? Okay, here's the last one. Try this one. All right, for this one, if you didn't know what it equaled, we know that it equals something, so you can set it equal to x. Good, we do know what it equals, but if you didn't, we would set it equal to x. You could do the wraparound, you get 36 to the power of x equals 6. And maybe on this one, you have to actually make this side. You have to make this side the base with the same. So obviously, we have a 6 over here. We want to make this side with a base of 6. So this is 6 to the second power. So 6 to the 2x equals 6 to the first power. And now that they have the same base, we can say that 2x equals 1, which means that x equals 1/2. Now, from what I can see, most of you guys are really good about doing this in your head, and so you don't need to actually do all this work for it. That's totally fine. You do not need to do this work. It is not required to do this work. But some of you guys might have a hard time figuring out in your head how to actually go about getting the right answer. If that is you, please feel free to do this process to help you get the correct answer as you go through. All right, let's work on something new. Write down these two things that I'm about to highlight for you. Just what I highlighted. My hope is that these are very, very obvious for you guys. For this one, if you do the wraparound, it's obvious that b to the first power equals b, like what's written here, because anything to the first power is itself. And then it's obvious for this one that when you do b to the 0 power equals 1, it also makes sense because anything to the 0 power equals 1. So these next two examples that I'm about to show you guys, I actually don't want you guys to write them down because I want you guys to be able to do these examples in your head. I don't feel like they're necessary to write down because they're so easy. So look at this one. Shout it out. What is log base 9 of 9? 1. Good. Whenever you have log base something of the same number, it equals 1. And then what about log base 8 of 1? 0. Anytime you're taking a logarithm of 1, it always equals 0. It does not matter what the base is. Alright, I'm going to have you guys write one more thing down for me here, and we're going to do 2 more examples like that. So, inverse property of logarithms. Write down those 3 things that I highlighted. For this first one right here, again, I hope this is obvious that when you do the wraparound, you get b to the power of x equals b to the power of x. That's obvious. So the little shortcut for this is that the base of the exponent, the base of the logarithm, kind of cancel out with the base of the exponential part, and you're just left with the exponent of b, which is x. Same thing for the second one. When you convert it into logarithmic form, you get log base b of x equals log base b of x, and that's from doing the reverse wraparound. So starting with the base, log base b of x equals log base b of x. And again, for this one, I would hope that you guys can notice that the b here with the log b there cancel, and you're just left with the x. So again, these next 2 examples, please do not worry about writing them down. I just want you guys to shout out what you get for the answers. So for this one, what is log base 7 of 7 to the 8th? Good. The log base 7 cancel out with that 7, and it just equals 8. That's something that I want you guys to be able to do like that. Just at the drop of a hat, you guys should be able to just kind of tell me exactly what that is. What about this one?
That one is...
What is log base 3 to the power of log base 3 of 17? Beautiful, 17. Good. And again, the 3 cancels out with the log base 3 in order to get that 17. All right, here's the last thing we're going to do for today's notes. I want you guys to graph these 2 equations. So graph these. Create a table. Create an XY chart as a table and then graph it. Good. Hopefully you guys used the points where... hopefully you guys use these points. So like -2, -1, 0, 1, 2. So when you plug them into the exponential function, you get 3 to the -2, that would be 1/9. 3 to the -1, that would be 1/3. 3 to the 0 would be 1. 3 to the first is 3, and 3 squared is 9. So when I graph these, did you guys graph them? You get 0, 1, 1, 3, 2, 9. And then on the other side, you get -1, 1/3, -2, 1/9, so on and so forth. Can you tell me where this graph has a asymptote? Good. It has a horizontal asymptote at y equals 0. So I can draw in a horizontal asymptote, and I'll do it in green so you guys can see it. A horizontal asymptote right here at y equals 0. Now, who was able to successfully graph by hand, not with a calculator, but by hand, log base 3 of x?
Isn't it the same thing, but it's tilted?
It is, but how do you figure out exactly where the points go? Here's how you do it, by the way. They are inverses of each other, which means it's a reflection across the line y equals x. So all of these points are essentially flipped on the logarithmic function. So if you plug in these values to log, you'll get these values for x. For example, what is log base 3 of 1/9? It is -2 because that's what the power of it is if you put the bases the same. Log base 3 of 1/3 is -1. Log base 3 of 1 is equal to 0. Log base 3 of, 3 is equal to 1. And log base 3 of 9 is equal to 2. So to plot this one, you plot them, but all the points are backwards. So you plot 1/9, -2, 1/3, -1, 1, 0, 3, 1, and 9, 2. And you guys can connect them like this. Where does this graph have a asymptote or an asymptote? Good, at x equals 0. So I'll put that one in yellow or orange so you guys can see it. So right here at y equals 0, there's a vertical asymptote for this graph. And again, if I draw this line that kind of goes down the middle, you guys can see that these are reflections across the line y equals x. So notice that they're a mirror image of each other. That's because the exponential function and the logarithmic function are inverses of each other. So if you found the inverse of one, you would get the other one essentially. All right, any questions about that so far? Beautiful. So, that's all we're going to do for today. We'll finish up the rest tomorrow. You guys can go ahead and pack up.